will begin impacting the New England offshore Monday. High winds and high seas expected to accompany the storm.
When you think about the population growth along the coast, there's a tremendous amount of assets, particularly homes in the coastal zone, that are particularly vulnerable to hurricanes. Over the last few decades, there's been a lot of improvement in the prediction of storm tracks, but very little improvement in the prediction of storm intensity. In particular, we're interested in cases of storms that undergo what we call rapid intensification.
Well, the Hurricane and Severe Storm Sentinel mission is dedicated to trying to understand hurricane intensification. So whether a hurricane will be a tropical storm, whether it will be a Category 1 or Category 2 or Category 3 hurricane. And this is really important because a category of a hurricane is the intensity of the winds associated with a hurricane. So being able to predict the difference between just a tropical storm, a Category 1, up to a Category 5 is really crucial to saving lives and lessening damage and so forth, particularly saving lives.
Well, the HS3 mission is based out of the Wallops flight facility in Virginia. The intention for the field campaign is to have 2 Global Hawks. The Global Hawks are really a new aircraft for doing hurricane studies. They're both unmanned aircraft designed to fly at very high altitudes, between 55 and 65,000 feet, and they have a flight duration of up to 30 hours. When we did previous hurricane field campaigns based in a place like Florida, we'd have to wait for the weather to come to us. With the Global Hawks, we can go to the weather.
The benefit of HS3 compared to any other hurricane mission is the fact that we have these planes able to fly upwards of 24 hours, and being able to monitor a storm for that long period of time and getting constant data, we can actually hopefully catch those changes in intensification, formation, rather than some of the data we've had before where we can fly for a few hours on the storm, but then we have to return because our planes can't fly for that long. So now we have a plane that'll be over the storm getting constant data, and we can really see changes in the storm.
There's 3 main science goals associated with the project. One is to look at the role of the large-scale environment, particularly a feature known as the Saharan air layer. It's a very hot, dry, dusty air mass that comes off of Africa, and some people argue that it actually helps to form storms, and others argue that it suppresses storms. Another goal is to look at the inner core processes, what's happening in the eye wall and rain bands of the storms, particularly the role of deep thunderstorms within the hurricane and whether or not they play an active role in spinning up the storm circulation. And then the last goal is to examine the question of to what extent are these processes predictable.
So we are flying our Global Hawks from Wallops, looking at the Atlantic, the Gulf, and the Caribbean. One Global Hawk has what we call an environmental payload, and it flies over vast areas around a hurricane. It measures the environment that a hurricane is embedded in. The second Global Hawk we have, we call that the overstorm payload. So instead of sampling the vast area, it goes right in to look at the eye and the eye wall and the inner core processes of a hurricane.
So it's really very useful, I think, for the scientists. They really like this platform because they can all be on the ground and getting their data almost real time from the aircraft. And they can make decisions about the flight. We can change the flight track. We can modify our positions based on where the storm is. So we actually have a control room on the ground. We have 2 of them now, and it's very exciting with this project. We have one at Edwards Air Force Base in California, and we have one here at Wallops Flight Facility in Virginia. So it's basically like a trailer. It's been specially designed for Global Hawk. So when we're in the control station, we're just like a normal cockpit, except it happens to be on the ground.
Now the scientists sit in a separate trailer called the Payload Mobile Operations Facility. We have computers sitting in front of us. We bring in satellite information. We bring in forecasts.